Alright, these are 10.1 examples to give us a little extra practice in identifying, classifying, and labeling polynomials. So in this first example, we want to determine if the following are polynomials or not. So the key to determining if something is a polynomial is to look at its exponents and see if they are all whole numbers. That means anything with an exponent that's negative is not a polynomial. Anything with an exponent that is a fraction is not a polynomial. Anything with an exponent that is anything with a variable that has an exponent that's negative or an exponent in the denominator, so a variable in the denominator, would be also not a polynomial. So let's look at this first one here. We have a -4 right there. So this is not a polynomial because it has a negative exponent. Here we have a +4 and then no exponent at all. So the answer here is yes, this is a polynomial because there's nothing here that tells us it's not. Here we have a +2, an invisible +1, and no exponent at all. So yes, again, we are a polynomial because there's nothing here to tell us that it's not. It's fine to have fractional coefficients. It's fine to have negative coefficients. What we're looking at here are the exponents. For D, we have an x to the 4th, which is fine, but here we have an x in the denominator. 14 over x equals 14 times x to the -1. Remember, we make a negative exponent positive by putting it on the bottom of our fraction. So if we have a variable on the bottom, it has to have a negative exponent to have put it there. So this would not be a polynomial. So not a polynomial. Here we have a fractional exponent, x to the -1, or x to the 1/2. So this is no, because it has a fractional exponent. Here we have 12x, which is 12x to the 1, and here we have 3 times the square root of x. Now remember, the square root means you have 3 times x to the power of 1/2. A fractional exponent sends us under the radical, so a radical gives us a fractional exponent. So if this is a fractional exponent, then our answer is no, because we had a fractional exponent as a variable under the radical. So those are some scenarios where you might not have a polynomial and some examples of actual polynomials. Next, we'll classify these as monomials, binomials, or trinomials. Remember, what matters here is the number of terms you have, not the highest exponent you have. Here we have 2 terms separated by subtraction, so we have a binomial. Here we have 2, 3 terms separated by addition, so we have a trinomial. Here we have several numbers, but they're all combined through multiplication. So we only have 1 term. That gives us a monomial. Here, again, we have 2 terms separated by subtraction, so we have a binomial. Here I have 2, 3 separate terms, so I have a trinomial. Here, I have x divided by 9. Now remember, if the x is on the top of your fraction, that's fine, because when you divide by 9, what you're saying is you have 1 over 9 times x. And that's fine. You can have a fractional coefficient, just not a fractional exponent. But in this case, we're fine, and we just have that 1 term separated by division, but not addition or subtraction. So we just have the 1 term, which gives us a monomial. Now we'll look at writing polynomials in standard form. Writing a polynomial in standard form simply means reordering the terms so that your biggest exponent is all the way to the left, and then your exponents go down to the right. It doesn't matter if you skip some exponents. What matters is the order that they're in. So here, my highest exponent is this 2. I have no exponent here. I have an invisible exponent of 1 here. So I need to put this negative 14x squared first. Remember to keep your negative sign with the number that follows it. Then I have a positive x to the first, so plus x, and then I put my constant term, or my term with no variable, at the end. Here, my highest variable term, or my highest exponent, is a 5, so I have 7x to the 5th. Then I have a third term, so I say plus 9x to the 3rd. And then I have an x squared term, so I say plus x squared or plus 8x squared. So again, it doesn't matter that we skip the 4th term. It doesn't matter that we don't have a 1 term or a constant term. What matters is that our exponents go in order all the way down. And last, I have a 1, I have a 2, and I have nothing. So I have 4x squared plus 16x minus 4. You might be asked to determine if a polynomial is in standard form. You want to look and see, okay, this one goes from 3 to 2, so far so good, but then from 2 up to 5, so that's not standard form. You'd need to rewrite it in standard form. Last on these examples, we will talk about the degree and type of polynomials. Degree is determined by the highest exponent. So, our highest exponent between 4 and 1 is 4, so the degree is 4. Pretty easy. And our type is quartic. There are 5 types of functions you'll need to know: constant, linear, quadratic, cubic, and quartic. And those go up from 0 through 4 degrees. There are 5th degree functions and 6th degree functions. We won't really deal with naming those in this class. We might see them. You might be asked to identify their degree, but you shouldn't be asked their name. For b here, my highest exponent is a 3. So regardless of the number of terms I have, now I'm looking at my highest exponent. So this is degree 3, which gives me a cubic polynomial. Here, my highest exponent is 2, so my degree is 2. And my type then would be quadratic. For d, all I have is this 9. That means that I technically have an x to the power of 0. Anything to the power of 0 is 1. And 1 times 9 is just 9. So if I have a 0 exponent, my degree is 0, and my type is constant. Because no matter what, I will always be at 9. For e, my highest exponent is my invisible exponent of 1. So my degree is 1. And my type here is linear. Remember, invisible exponent has a degree of 1, and the type is linear. Last, I have a highest exponent of 3, so my degree is 3, and my type, again, is cubic. So degree is based on the highest exponent, type is based on that degree, and we only need to know the names up through a 4th degree polynomial.